rubble, dust hanging in the air, a blown-out doorway, heavy breathing inside a steel helmet. An American infantryman flattens himself against a stone wall. Flaking paint scrapes his sleeve, his hands tighten around a weapon that looks like it came out of a machine shop, not a factory. Bent sheet metal, rough welds, nothing polished, nothing elegant. Footsteps echo down the alley, no time to line up a perfect shot. He leans out just enough, squeezes the trigger. The sound isn't the fast, rattling chatter of most submachine guns. It's slower, deeper. Chug, chug, chug. Each hit feels close, immediate. The noise bounces off collapsed walls and open doorways. No long muzzle flash, no wild spray, just a short, heavy burst. Then it's quiet again. The soldier pulls back into cover and looks down at what he's holding. It looks like a pipe gun welded together in somebody's garage. It was cheap, it was ugly, and in close quarters fighting, it was exactly what you wanted. It was called the M3, and it was designed to be cheap. Stamped steel, minimal machining, built fast, built in huge numbers. But what started as a cost-cutting measure turned into something else entirely. Because in close combat, the M3 became one of the most effective tools an American infantryman could carry. Not because it was refined, because it was built for the real world. Mud, stress, no time for maintenance. It fired .45 ACP, a heavy round that hit hard at short distances. And it ran at a slow, deliberate rate of fire, around 450 rounds per minute. Slow enough to control, fast enough to end a fight. On paper, it looked crude. In the kind of fighting that happens at doorways and hedgerows and inside ruined buildings, it made sense. The real enemy wasn't German infantry, it was logistics. When the United States entered the war, it suddenly needed submachine guns by the hundreds of thousands, not eventually. Immediately, infantry units, tank crews, paratroopers, everyone wanted compact automatic firepower for close-range fighting. On paper, America already had an answer. The Thompson. It was accurate. It was well made. It hit hard. It also cost a small fortune. Each Thompson required extensive machining, skilled labor, and time on precision tools. Early war production ran well over $200 per gun. Even later simplified versions were still expensive and slow to build. That might work for a police force. It doesn't work for a global war. Meanwhile, Europe had already shown a different approach. The British were stamping out Sten guns from sheet metal. The Germans were mass-producing MP-40s with welded receivers and simple internals. These weapons weren't elegant. They were fast to make. That was the lesson American planners couldn't ignore. The U.S. Army Ordnance Department wasn't looking for perfection. They were looking for something that could be built quickly, cheaply, and in enormous numbers, on production lines that were already stretched building rifles, machine guns, artillery, trucks, and aircraft. Every milling machine was booked. Every skilled machinist was already assigned. There was no room for a precision submachine gun. What they needed was something closer to industrial plumbing, stamped steel, simple welds, minimal machining, a weapon that could be assembled by semi-skilled workers on automotive-style production lines. Because in a world war, firepower isn't just about ballistics, it's about throughput. It's about how many guns you can put in crates this month. And that's where the M3 begins to make sense. It wasn't created to be admired. It was created to be manufactured. In an ideal world, every soldier gets the best weapon money can buy. In a world war, what matters is what you can build tomorrow. Development started in 1942, not in a research lab, not in a designer's studio, on factory floors. The requirement was brutally simple. Build a submachine gun in .45 caliber, make it compact, make it cheap, and make it fast. By late 1942, early 1943, the design was finalized and adopted as the M3. Combat use would follow in 1944 as American forces pushed deeper into Europe. There was no romance in the process. This wasn't about craftsmanship. It was about industrial math. The engineers stripped the weapon down to its essentials. The receiver was stamped from sheet steel instead of milled from solid blocks. Major components were welded together. Complex machining was avoided wherever possible. Only a handful of parts required real precision work. Everything else could be punched, bent, and assembled on production lines that looked more like automobile factories than gun shops. The result was something that barely resembled a traditional firearm. It looked improvised, almost crude, but that was the point. In 1943, each M3 cost roughly $20 to produce. Less than a fraction of what a Thompson required. That wasn't a coincidence. That was the design goal. What came out the other end wasn't elegant. It didn't have polished surfaces or graceful contours. It had flat panels, rough welds, and a wire stock that felt more like hardware than weaponry. This wasn't jewelry. This was throughput. The M3 wasn't designed to impress anyone holding it. It was designed to move down a production line as fast as possible, and then move straight into combat. And this is where the M3 stops being just a cheap gun and starts making sense. The technical manuals described it with 3 words: light, compact, rugged. But the real design philosophy was simpler than that. It was built to forgive mistakes. The M3 used a straight blowback system with an open bolt. No locking lugs, no complex timing, no delicate linkages, just mass, spring tension, and momentum. That kind of mechanism doesn't care much about dirt. There are fewer surfaces that have to mate perfectly, fewer parts that need to stay clean to keep cycling, wider tolerances where sand, mud, and carbon fouling can exist without immediately stopping the gun. You could drop it. You could drag it through hedgerows. You could run it after days without cleaning. It wasn't graceful. It was tolerant. Oh, and that mattered more than elegance ever could. Then there was the rate of fire. At roughly 450 rounds per minute, the M3 ran slower than most submachine guns of the era. That wasn't a flaw. It was deliberate. That slower cadence gave soldiers time to correct between shots. Short bursts were easier to manage. With practice, you could even walk single rounds out using trigger control. Instead of spraying ammunition, you could place it. In close quarters, that difference matters. And then there's the sound. The M3 fired .45 ACP, a heavy round that's typically subsonic in pistols and submachine guns. That means no supersonic crack, no sharp ballistic snap announcing the bullet's path. Now, this didn't make the M3 quiet. Far from it. But combined with its low rate of fire, the sound it produced was different from the high-pitched chatter of fast 9mm guns. Lower, slower, less directional. Not silence, ambiguity. In towns, hedgerows, and ruined buildings where echoes bounce off walls and debris, that ambiguity made it harder to immediately locate the shooter. And in close combat, even a few seconds of confusion can be decisive. The M3 didn't win fights with refinement. It won them by working when conditions were bad, by staying controllable under stress, and by delivering heavy rounds at exactly the distances where infantry actually fought. It wasn't engineered for test ranges. It was engineered for chaos. The real test came in 1944, not on a range, not in training, in Europe. The M3 first showed up in meaningful numbers with airborne and frontline units during the Normandy landings. Early reactions were mixed. Some soldiers hated how it looked. Others didn't trust something that felt so light and unfinished. But once the fighting started, a pattern emerged. This wasn't a weapon for open fields. It was a weapon for places where distances collapsed. In the hedgerows of Normandy, engagements happened without warning. One moment you were moving through brush. The next, you were face to face with someone on the other side of a dirt bank. In towns, it was corners and doorways, stairwells, hallways, rooms you had to clear one at a time. In ruined cities, it was rubble piles and shattered walls, 10 meters, 5 meters, sometimes less. This is where the M3 made sense. Compact enough to maneuver indoors, heavy rounds that hit hard at point-blank range, short, controllable bursts instead of high-speed spray. It wasn't about marksmanship, it was about reaction time. And then there was everything else: mud on boots, dust in eyes, sweat inside gloves. Soldiers were exhausted. Weapons went days without cleaning. Gear got dropped, banged, dragged, and soaked. This is where design philosophy shows up. The M3 didn't demand careful handling. It didn't ask for pristine conditions. Its simple blowback action and loose tolerances kept running when grit got inside, when lubrication burned off, when maintenance slipped. You didn't have to baby it, you just had to pull the trigger. This is the same lesson that keeps appearing in wartime engineering. You don't design for ideal conditions. You design for failure. You assume weapons will be neglected. You assume soldiers will be tired. You assume dirt will get everywhere. The M3 was built around those assumptions, and in the close, ugly fighting of Western Europe, that mattered more than finish quality or machining precision. It wasn't pretty, it was present, and in combat measured in meters, that was enough. But none of this means the M3 was perfect, far from it. Early models had real problems. Some parts were fragile. The original cocking system, which used a separate crank-style handle, could bend or break. Magazines were inconsistent, and feeding issues showed up if they were damaged or poorly made. In some units, the gun earned a reputation for feeling flimsy, not unreliable. Flimsy. Soldiers were used to heavier steel and solid wood. The M3 felt hollow by comparison. To many, it seemed disposable. Those complaints didn't go unnoticed. By late 1944, the Army introduced a revised version, the M3A1, and the changes were telling. The external cocking handle was eliminated entirely. Instead, soldiers charged the weapon by pulling directly on the bolt through a slot in the receiver. Fewer parts, less to break. As small internal components were simplified, manufacturing steps were reduced even further. Maintenance became easier. Field stripping got faster. Nothing flashy, just practical fixes. The M3A1 wasn't about improving performance. It was about improving survivability of the system. Fewer moving parts meant fewer failures. Fewer unique components meant faster repairs. Less complexity meant less training required to keep the gun running. By the time the M3A1 reached frontline units in meaningful numbers, most of the early complaints had faded. not because the weapon had become elegant, but because it had become easier to live with. And that distinction matters. This wasn't a gun designed to impress soldiers on deity parade. It was designed to stay functional in mud, in exhaustion, and under neglect. That's the difference between something that looks good on paper and something that holds together in a war. Over time, the M3 picked up a reputation. Some of it deserved, some of it didn't. One of the most common claims is that the grease gun was disposable, that it was meant to be thrown away, that it was basically wartime junk. The documents don't support that. Yes, it was designed to be cheap. Yes, it was optimized for mass production. But no military plans around issuing weapons assume you can simply discard them in combat. Soldiers don't get replacements on demand. Supply lines break. Units get cut off. Whatever you're carrying is what you have. The M3 wasn't built to be disposable. It was built to be producible. That's a very different thing. Once it reached the field, it had to last. Through mud, handling, and neglect, just like everything else. And it did. Another myth is simpler. It looks ugly, so people assume it must be bad. But aesthetics were never part of the design brief. The M3 wasn't competing for contracts in peacetime trials. It wasn't meant to impress generals or weapons collectors. It was built to solve an industrial problem. How to arm hundreds of thousands of troops quickly using factories already overloaded with war production. Flat panels instead of curves, welds instead of polish, wire instead of wood. Those weren't signs of incompetence. They were signs of prioritization. Every visual shortcut represented hours saved on a production line. Every simplified part meant fewer skilled workers tied up on a single gun. This is where perception diverges from reality. People see the grease gun and think, cheap. The Army saw it and thought, scalable. Collectors see rough finish. Quartermasters saw throughput. And infantrymen, fighting in alleys and hedgerows, didn't care what it looked like as long as it fired when they needed it. The M3 didn't succeed because it was beautiful. It succeeded because it fit a very specific niche. Close-range fighting, minimal maintenance, mass issue. Once you judge it by those criteria instead of appearances, the story changes. Put next to its contemporaries, the contrast becomes clearer. Take the Thompson. The Thompson was a premium weapon, heavy steel, extensive machining, solid furniture. It felt substantial in your hands, and it performed well. But it was never designed to be scaled across an entire wartime economy. It asked for skilled labor, precision tooling, and long production cycles. The M3 asked for stamped sheet metal and welders. The Thompson represented craftsmanship. The M3 represented industrial reality. Different philosophies aimed at different problems. Compared to fast-firing 9mm submachine guns, the difference showed up in combat behavior. Those weapons emphasized rate of fire, high cyclic speed, dense bursts. The M3 went the other way, lower cadence, more control. Instead of a rapid chatter, you got deliberate pulses. Instead of lightweight 9mm rounds, you got heavy .45 projectiles designed for short distances. This didn't make the M3 superior at range. It wasn't meant to be. It was built for fights measured in meters, inside buildings, across narrow streets, and through doorways, where recoil management matters more than muzzle velocity, where placement matters more than volume. The M3 wasn't trying to be the best submachine gun in every category. It was optimized for one specific role: close-range combat, under bad conditions, by tired soldiers. Once you look at it that way, the design stops looking crude. It starts looking intentional. So go back to that alley. The dust, the broken doorway, the soldier pressed against cold stone, counting footsteps. Now you understand what he's holding. Not a precision instrument, not a masterpiece of machining, just stamped steel, rough welds, and a heavy bolt riding inside a hollow tube. But it works. It works when it's dirty. It works when maintenance slips. It works when hands are shaking and decisions have to be made in seconds. The grease gun wasn't elegant. It was forgiving, and in close quarters fighting, mud on your boots, adrenaline in your chest, and an enemy 2 meters away, elegance doesn't matter if your weapon stops running. The M3 didn't win wars by being beautiful. It earned its place by being present when everything else started to fail. It wasn't the nicest gun on the battlefield. It was the one that kept firing when the world came apart.